Hello and welcome to Autology, the podcast that brings you the latest on automotive technology. Today's podcast is called Shifting Dynamics in the Lithium Iron Phosphate Battery Market. And you're here with me, Matthew Beecham, and Ali Adim, who is manager of our battery team here at S&P Global Mobility, and Dan Blondell, CEO, director and founder of Canadian battery materials maker Nano One. A very warm welcome to you both and thank you very much for joining Autology.
Thank you. Pleasure to be here.
In this episode, we are focusing on lithium iron phosphate batteries, or LFP for short, and their increasing adoption in the West. LFP batteries, known for their stability, long lifespan, and resistance to heat degradation, are popular in China and are now making their way into North America. Automakers such as Tesla, Ford, and Rivian have already expressed their intention to incorporate LFP batteries in their electric vehicles. And as the technology advances, the performance gap between LFP batteries and other batteries types are expected to narrow too. However, wider adoption in the low-cost sector requires addressing some supply chain challenges. So the first question that I have for you, Ali, is what are the key factors influencing the outlook for LFP battery utilization in North America, please?
It is important to differentiate between the potential with and without legislative constraints. Without the constraints, in my view, LFP batteries show great potential. They are not only significantly cheaper than nickel-based chemistry, but also offer a lot of interesting features like better cycle life, better safety, and so on and so forth. As a result, LFP batteries have already achieved a remarkable 65% market share in China. And in China, as a result of the low prices of LFP, the new generation of EVs have reached to almost the price parity with internal combustion engine cars, which has been the main goal of the EV industry since its inception. In North America also, we see a great appetite to adopt LFP batteries. Car manufacturers like Tesla and Ford are already using them in their vehicles, especially for cheaper models. However, legislative constraints are hindering the actualization of this potential, especially Inflation Reduction Act or IRA provides tax credits for the customers of the EV models that are sourcing their batteries from North America and the raw materials from the countries that have free trade agreements with the US. In addition, the foreign entity of concern designation within the IRA disqualifies the batteries that use components that are coming from Chinese markets. And since the majority of the LFP batteries are produced in China, it has become almost impossible to have the vehicles that can satisfy the IRA tax credits criteria. And without the tax credits, LFP batteries lose their main value proposition, which is the cost competitiveness. So as a result, our forecast for the share of LFP batteries in North America in 2030 is quite modest. So it reaches to 15% in 2030, which is much smaller than China, which is 60%, and Europe, which is expected to reach 30% by the end of the decade.
That's very interesting, Ali. Thanks very much. And what's your take on this, Dan?
Well, there's certainly a lot of different dynamics at play here. As Ali points out, companies and governments have made lots of decisions here that they felt were right at the time and will probably need to be adjusted. We saw it in China. They would make decisions at the beginning of the year and change them in the next part of the year because they'd see really the unintended consequences. So I very much think that will happen as well. So there's an evolutionary component here. For example, NMC battery chemistry now has an important foothold both in US and Canada and in Europe as well, and largely due to foreign investment from Japanese and Korean companies collaborating with American auto producers to leverage clean energy, skilled workforce, immigration policies, the IRA, responsible mining, world-class environmental standards. There's a lot of factors here driving all of this, obviously all aiming to integrate with the US automotive supply chains. But look, as a Canadian, I'd like to quote the great ice hockey legend Wayne Gretzky, which says, "Skate to where the puck is going to be, not where it has been." And I think it's really important for us to have a forward-looking view here and not just respond to where the market seems to be going. And so this is where LFP comes in, and it's really by comparison, it's very much in its nascency outside of China, with automotive companies such as GM and Ford and Tesla and Volkswagen, and various battery companies such as LG, Samsung, and even more nascent companies like our Next Energy in Michigan, all committing to a future that will include LFP, but it's not there yet. And the benefits of LFP are key to low cost, mass market electric vehicle adoption, but they're also important in heavy duty applications such as stationary storage, fleet vehicle applications. So, Ali, as you point out, LFP has already reached a market share of 65% in China, and they actually control today about 99% of the world's market. So, we in the North America with the IRA and with the foreign entities of concern are discouraging collaboration with China. U.S. legislation and policy is also indirectly favoring NMC producers from Korea, Japan, and Europe as a result. And this has the unintended consequences of tying supply chains to China. And that's because they control the vast majority of refined nickel, manganese, cobalt, and NMC precursor. The processes to make these critical minerals are capital and carbon intensive, and they are difficult to permit the waste streams that are generated in these processes in a North American context. And it's virtually impossible to copy and paste them here in North America and the supply chains and be in any way competitive with China. So these are all of the dynamics that are at play. And given these challenges, I would argue that it is much easier to build and diversify the raw material supply chain and midstream production that is needed for LFP cathode materials outside of Asia than it is to do for NMC, simply because the access to iron, the access to refined iron and phosphorus is going to be much easier outside of North America than it is for the NMC precursors. And doing so would necessitate domestic production of low cost, safe, and long lasting LFP batteries, and would help localize and secure supply chain. So we're much more bullish on the numbers and believe that the dynamics will change here over time, and certainly as the legislators figure out where they may have gone a little bit wrong and tip it in favor of the batteries that will deliver us the lowest costs and lowest footprint technologies.
That's great. I see. Thanks very much indeed, Dan. I do like your ice hockey quote there from the great one about focusing on the future to remain ahead of the curve. I wonder, can I now ask or get your thoughts on how the state of the LFP battery supply chain in North America impacts the market, Ali?
Sure, Matthew. In terms of the battery production, North America relies heavily on South Korean players like LG Energy Solution, Samsung, and SK On. All three players have plans to produce iron-based chemistries. For instance, LG has already started producing LFP cells in China, but for the stationary applications. And SK On has plans to adopt LFP from 2026. Samsung, on the other hand, is focusing on the new generation of iron-based chemistries that has manganese in it, which is called LMFP. So all of these suppliers are expected to start producing iron-based chemistries also in North America. Despite all the mentioned legislative pressures, Chinese players are still interested in North American market. Chinese companies like CATO are trying to explore new ways like licensing to penetrate this market. We have announcements from Ford and GM that are trying to explore this pathway. In addition, Gotion has already begun producing LFP cells in the US for the energy storage application. There are also some startups in this domain, like our Next Energy, which is operating at a pilot scale. Moving further upstream, on the other hand, the situation is less favorable. Cathode active material is the key differentiator in the LFP value chain. And there's very little production of cathode active material of LFP outside China. Chinese players have been dominating this area for many years. They have optimized the processes and nurtured very efficient supply chains. In North America, we have new players like Nanowan, ICO that are striving to reach mass production in this decade. When we look at the required materials for LFP, we see a clear advantage of this chemistry over the NCM when it comes to the raw material sourcing. Because LFP raw materials, the ingredients are much more globally distributed. For instance, phosphoric acid, one of the main precursors of the LFP synthesis, is already in mass production in North America. When it comes to iron, there are many pathways for the LFP synthesis that require different types of compounds like ferrous oxide or elemental iron, and all of them are already mass production in the region as well. And this is in direct contrast with the situation of the NCM metals like nickel and cobalt, which are highly concentrated in certain regions of the world, especially in China for the refining part of the supply chain.
Yeah, that's very interesting too. Very, very, very interesting, Ali. Thank you. Anything more from your side, Dan, on this?
Yeah, look, Ali, appreciate how you kind of laid that out, and I think we're very much in step on that. The Chinese control over the nickel, manganese, and cobalt actually lays the ground for LFP adoption around the world, simply because the supply chains can be more distributed. And I would just add that this tension is actually quite central to the Inflation Reduction Act and the North American battery conundrum. China controls LFP battery manufacturing, but also controls the refining and NMC raw materials, as we both talked about in the previous questions. LFP battery manufacturing can eventually be learned and mastered with the help and collaboration of our allies and our friends, and even China. But the supply chains and the processes have to be entirely reinvented if we are to truly diversify and eliminate the environmental issues and address the challenges of making them even more economically viable. It's a tall task for sure, but I believe it is more easily done with LFP. Historically, LFP dominated in China because they had the combined advantage of major investment, production subsidies, consumer incentives, and lax environmental standards, all flourishing without the enforcement of cost-prohibitive LFP patents that were invented in North America and that also hindered growth in North America and Europe. Those patents have largely expired now, and LFP production methods in China, which have relied largely on low-cost iron sulfate tailings that are uniquely generated by an outdated and poorly regulated titanium dioxide refining industry. And this allows wastewater and energy inefficiencies and the propagation of millions of tons of waste disposal. The world cannot simply now copy LFP with the patents all removed and copy these methods without actually the security risk of relying on China's low-cost sources of iron and without inheriting all of the underlying environmental downsides. So it's important to note that LFP gained considerable momentum when China stopped. This goes back a little ways, but if you go back 7 years or so, China was incentivizing NMC, and when it stopped incentivizing NMC, LFP started to gain considerably in momentum, and that led to the development of new LFP battery packs that had started rivaling NMC on energy density and range. You can see LFP-driven cars that are approaching 600-700 kilometer range now even in China. So fast forward all of this to now, and as I said, the North American patents have expired, and this has opened the door to LFP production in all regions outside of China. So as LFP production ramps up, so does the need for battery materials. But as with NMC, the wastefulness of the China supply chain is a major impediment to refining, permitting costs and growth in the West, particularly under our stricter Western environmental standards. However, unlike NMC, LFP can leverage, as Ali pointed out, the large existing refining capacity in North America and with a number of the free trading and like-minded nations that supply us using IRA-compatible high-grade iron made with renewable energy and formed with innovative process that eliminate waste. Notably, high-purity iron was added to Canada's list of critical minerals just earlier this month on June 10th, along with phosphorus and silicon metal. Strong demand for LFP will eventually create a need for purified phosphoric acid. There's enough annual capacity to supply maybe the first 500,000 tons of LFP outside of China, with expansion and investment to follow in phosphorus mining and refining. So really, we believe that LFP has a tremendous opportunity. It can use lithium carbonate as input, and that enables battery-ready offtake directly from lithium producers in North America without going through lithium hydroxide or having to build out the capacity and the refining capacity to make lithium hydroxide. This will offset NMC's need for the costly and energy-intensive conversion from lithium to lithium hydroxide, and will play, I think, a fundamental role in the cost reductions and supply chain development for LFP. And then maybe lastly, there's an opportunity with LFP to create the cleanest, greenest, lowest cost, and most IRA-compatible supply chain in the world, while also meeting the emerging demand for low-cost environmental imperatives in both stationary energy storage and electric vehicle batteries in North America and in Europe and other regions in the world. If we get this right, it will unlock significant investment in the upstream. And I think that's really important because, of course, we need the mining, we need the refining, but until the battery and the material space is there, the investment is lackluster.
It's very interesting to get your grassroots perspective there, Dan, about just how palpable is the tension between LFP and NMC batteries in North American market. Ali, could you give us an idea of the main challenges faced by IRA-eligible LFP batteries in North America and how they affect their adoption, please?
Sure. So there are several requirements for the Inflation Reduction Act that must be met simultaneously for a battery to be eligible for tax credits. I will go through these requirements and criteria one after the other. The first criterion is that the battery must be produced in North America. Currently, the production of LFP batteries in North America is rather limited. However, our forecast predicts that LFP battery production in North America will reach to 86 gigawatt hour by 2030. The second criterion is that the critical minerals and the raw materials must be sourced from the countries that have free trade agreements with the US. This qualifies most of the Chinese batteries as they rely heavily on the raw materials that are coming from China. However, it is not difficult to build a supply chain for the critical minerals, which is eligible for Inflation Reduction Act in North America. Countries like Chile and Australia, the largest lithium producers, as well as Morocco, which has the largest phosphorus reserves in the world, are among FTA countries. And the third criteria, which is arguably the most stringent one, requires that batteries must not include any component sourced from China or other entities of concern at any stage of their supply chain. This criterion, which has been applied to the battery components since the beginning of this year, by battery component, I mean the battery cells, module, and packs, has led to disqualification of a lot of vehicles that have been using LFP batteries sourced from China, which includes a couple of models from Tesla, actually. However, theoretically speaking, once the battery cell and cathode active materials are domesticated in the region, it is feasible to meet this criterion considering the size of the raw material production capacity in the FTA countries.
Thanks a lot, Ali. Dan, I can see you nodding in agreement there. What's your take on this?
I was indeed in agreement with pretty much everything Ali said there. And I think it's worth noting and pointing out that NMC is also impaired by the IRA equally as LFP because the raw material supply chain is very, as I said before, and as Ali pointed out, it's very tightly controlled by China. And Western refiners are reluctant to invest billions of dollars required. And we're seeing even some of that happening today. Some of the big Western producers are pulling back investment in nickel refining. And this increases the reliance on China and makes the IRA compatibility for NMC very challenging. Korean cathode producers who, by and large, import their NMC precursors and their lithium hydroxide from China, they're struggling with this predicament. And interestingly, this has fueled a shift in policy in Korea and a strategy towards LFP, and which brings that into their ecosystem. And LFP is potentially easier to make IRA compatible and competitive in not only in Korea but in a North American context, in Morocco and various other places where we're seeing emerging opportunities. So we have to strike a similar balance here in North America with our free trading partners to leverage this unique opportunity in LFP. We have large resources in lithium, iron, phosphorus, again, as Ali pointed out, and large scalable refining capacity already in place for high purity iron, purified phosphoric acid, and this cannot be realized without the domestic production of IRA compatible LFP cathode materials and batteries. So very, very important. Collaboration is essential for LFP. We can't do this alone. No one party can do it alone. So not only battery producers from Korea and Japan, such as LG, Samsung, SK, Prime Planet from Japan, but also cathode producing experts such as EcoPro, Sumitomo Metal Mining, POSCO. And lest we forget, there is much to learn from China's LFP experiences. So we don't want to be doing this, reinventing the wheel on our own. As we ramp up volumes to be economically and environmentally competitive, I think we have to look at China, how China has done it, and learn from the lessons there, learn from what has been done right and what has been done wrong. I think history and the actuality of how it's played out in China should play a very important role in how we push this forward.
Thank you. There's a lot of fuel for thought there. While we've got you both with us, could I get your thoughts on what is the cost competitiveness of LFP batteries produced in North America compared to those produced in, say, China? Ali.
So our upcoming report on the battery price indicates that LFP batteries produced in North America projected to be on average 10% more expensive than the Chinese counterparts. Please bear in mind that I'm talking about the average values, and you for sure would be able to find even cheaper LFP batteries produced in China. And however, on the bright side, the batteries produced in the US benefit from a generous $35 per kilowatt hour production tax credit. In addition, we have other protection mechanisms in North America. Recently, we saw a quite sharp hike in the import tariffs for the batteries coming from China to 25%, which creates an additional barrier to the import of LFP cells from China. So this means that not only Chinese cells will lose the IRA tax credits, but also are penalized by 25% import tariffs, which completely evaporates their cost advantage, basically. However, one criticism of these new tariffs is that they might isolate the North American battery industry from global competition, which might lead to higher inefficiencies in the region. These inefficiencies, in turn, could result in higher costs for the customers. Relying heavily on protective measures might pose a threat to North American industry. So, for instance, if the tariffs are suddenly removed, it can be disastrous for the local suppliers because they have been shielded from the global prices and they might not be able to completely compete with their foreign rivals. So it is really crucial to reach to a balance between protecting domestic supply chain and maintaining a healthy competition to ensure long-term sustainability and competitiveness.
Yeah, if I can add to that, I think certainly very important to have these policies in place. But long term, the industry can't rely on tariffs to be competitive with China. But I think we can rely on them to allow us. They need to be there for the interim, for the volumes to grow and to be competitive. So you've got this proverbial sort of carrot and stick. The tax credits are the carrot, The tariffs are the stick, but we need to do that. And I suppose while the impact of ring fencing this helps ease the competitive pressure in North America, the batteries and EVs outside of the US will just get cheaper and better. So I guess we have to learn to strike a balance. And I think that's the point. It's looking at it at the same point that you were looking at in a slightly different way. But we have to create that balance, not only to create valuable, sustainable, competitive markets here and let them grow and nurture until they can be competitive, but we also being able to ensure safe and secure access to energy storage. So there's obviously a market and economic element here. There's also a strategic imperative that is playing out here with the tariffs and the legislation. And I may add, look, we're all seeing a slowing in sentiment towards EV adoption, and that's largely governments and big automotive companies relaxing their ambitious projections from a few years ago. But I'm a cup half full type of personality, and I can see beneath the tepid news headlines. There remains large growth in electric vehicles and stationary storage sectors, with more demand than there is supply of batteries and materials, and the critical minerals. So sales may not be meeting projections, but let's keep in mind that industry is projecting between 8 to 10% of cars sold in North America this year to be EVs. I remain bullish on the long-term future of batteries in the North American supply chain. So as a case study, China is proving that society can be electrified with electric vehicles, with high-speed rail, with renewable energy storage. They invested early and heavily in the mining, refining, and chemical conversion of critical minerals such as lithium, nickel, iron, et cetera, into battery-grade inputs, precursors, cathode materials for LFP, NMC batteries. They have a 10-year head start, that's for sure. They control most of the battery supply chain, and they are very cost competitive. But it has come at great cost to the environment and global energy security. And therein lies the generational challenge and opportunity that cannot be realized by copying and pasting. We must innovate our processes and customize our supply chains for what works in North America, for what works in Europe, for what works in other areas, let's say in the Indo-Pacific region. Governments must foster growth, opportunity, and competitiveness with policy that leverages the support for LFP and NMC. Americans should add phosphorus and iron to the list of critical minerals. We've done it in Canada, as I said earlier, and this will help incentivize supply chain diversification and investment. And they must also support innovation in order to address the need for cleaner, greener, and diversified supply chains. So a lot of moving parts here, and it's really key that it gets put in place to nurture high volume production that can then become competitive with China.
Very interesting. It's a continual balancing act. I wonder, Ali, could you share any more snippets from S&P Global Mobility's latest research, please? I'm thinking maybe along the lines of what are the potential growth opportunities for LFP battery manufacturers in North America?
Sure, Matthew. So, as I mentioned earlier, the future of LFP batteries in North America is heavily influenced by legislative factors. Our baseline forecast assumes that the Inflation Reduction Act and import tariffs will still remain in place after the US presidential election. And with this assumption, we project a modest growth in the market share to reach 15% by 2030, resulting in the demand of approximately 100 gigawatt hour. This demand is primarily driven by volume segments like C and D in North American market. In comparison, Europe, which has a rather more open approach to Chinese investment, is expected to have a larger market share to reach about 34% of iron-based chemistries, including LFP and the new generations. And as mentioned before, this disparity can be largely attributed to the legislative factors. In addition, there's a significant opportunity for LFP batteries in the stationary storage sector due to their remarkable cycle life. For instance, Tesla recently announced that they would like to acquire some of the unused production equipment from CATL to produce LFP cells in Nevada, but for the energy storage application. So that's also a pretty remarkable trend to to monitor in the region.
Thanks very much, Ali. Insightful research there. Dan, on that point of stationary storage, what are your observations?
Well, the demand for LFP batteries in stationary storage is overshadowed by the kind of ebbs and flows and headlines in EV demand. We don't really hear about energy storage in the news cycles, but stationary storage it's going to be very important, and it will grow organically all over the world, starting in small volumes without the supply chain worries and localization that will eventually that will hinder growth in the automotive sector. And so, LG, Goshen, you mentioned them earlier. They're establishing LFP battery production, targeting stationary storage in North America. They're building up facilities in Arizona, Michigan. Our Next Energy, Saft, and a number of other smaller producers are also targeting LFP for renewable energy, in industrial and recreational storage applications. So I agree that the market share will be moderated by the IRA and tariffs, but China's kind of rock solid control of NMC supply chains may very well tip the market and the market share and industrialization towards LFP with stationary storage, ESS, driving really some of the early production volumes until they get large enough to be able to support the automotive market. And we're already starting to see this play out in Korea as they shift from NMC to LFP. So I think there's some strong signals around the world that we can't ignore, and that will be duplicated in North America and Europe.
That's great. Time will tell. How does the environmental sustainability of LFP battery production in North America compare to other battery technologies? Ali, would you like to start?
Yeah, sure. So this year, actually, we published a new forecast that assesses the carbon footprint of the battery cell, comprising of various sources of emissions, direct emissions, or scope 2 and 3. So according to this new forecast, we see that LFP batteries actually have a higher carbon footprint compared to NCM type of batteries, especially high NCM. So in 2024, the global average carbon footprint of the LFP batteries was 79 kilogram of CO2 per kilowatt hour, while NCM 811 batteries had 59 kilogram CO2 per kilowatt hour. And this is primarily due to the lower energy density of LFP batteries, which results in higher emissions per kilowatt hour. And also, you have to remember that the majority of the LFP cells now are produced in China, which has a higher carbon intensity for the grid, as it is relying on coal-fired power plants. However, there's a significant potential to reduce the footprint of the LFP batteries, especially in North America, by leveraging abundant renewable energy sources. In addition, LFP battery doesn't use the nickel and cobalt metals that are very energy intensive. So there's still another great potential to lower the carbon footprint for the LFP cells to levels even below NCM emissions. In addition, we have to also remember that LFP batteries are known for their very impressive cycle life. Considering long cycle life of LFP batteries, the lifetime emissions of this chemistry can be even lower than the NCM type. So basically, for the stationary applications, the new generation of LFP cells can reach to over 15,000 cycles. And in the EV application as well, the battery can even outlast the vehicle. So that creates a lot of opportunities actually for the second life applications. And another important feature and advantage of LFP batteries is that instead of NMP as a solvent, which is a highly toxic material that poses a lot of risk both to the personnel working at the gigafactory and also the environment, LFP batteries use simply water as a solvent. So automatically you eliminate another environmental risk factor.
Dan, what are your thoughts?
Yeah. So look, I think we talked about this earlier. Renewable energy is going to be renewable energy is an essential ingredient, of course, but it is a limited and precious resource. So we do have to use it judiciously as stewards of the environment, not only by sticking our energy intensive processes at the end of the wires, but we also have to improve the efficiency of those underlying processes. So we can't be wasteful of the renewable energy. Last year, Nano One commissioned a third-party CO2 life cycle assessment with Minviro, and it was comparing LFP production. It was comparing NMC production made with the standard conventional processes in China and with Nano One's one-pot process. We did that comparison of the two processes under coal-fired power, under gas, under renewables, and we did it in China, US, and Canada. So really a broad broad data set here. And it showed that the reduction in CO2 emissions to be about 30 to 60% for LFP and NMC, with about a third to a half of that coming from savings directly from the one-pot process, not just from renewable energy. Just showing that there are significant improvements we can have in the processing of the materials that will cut down energy usage. The one-pot savings, it comes from combining precursor, PCAM, and CAM, and the coating processes. Because there are fewer steps, there's less equipment, there's smaller furnaces, there's no waste stream, there's no waste treatment, and we are able, of course, to leverage cleaner supply chains. And CO2 emissions in our study it was shown that could be 40% lower for LFP than with NMC. So on top of that, LFP has greater cycle life than NMC, as Ali aptly pointed out, can get up to 15,000 cycles. So that could deliver up to even greater, 5 times or more kilowatt hours over its lifetime. And that can drastically reduce the CO2 footprint of LFP batteries over NMC by just looking at it across the whole life cycle. Regarding water use, we have studies showing that the one-pot process for LFP uses about 80% less processed water than conventional LFP. And there obviously is an underlying cost and environmental advantage to that, but that, to give you a sense, that represents a savings of about 4,000 liters for every 75 kilowatt hour electric vehicle battery. So just to give it some context, and it's important to note that all of the water in a conventional cathode process ends up contaminated as wastewater, requiring treatment and capitally and energy intensive, while the one-pot process generates zero wastewater, and that is one of the significant advantages of the process. So support for innovation is critical to the midstream, particularly adopting cathode material production and refining in a North American and Western context. And that support is not only from government, but we also need it from investors and the entire battery sector.
That's great. Thanks very much, Dan. It seems that Asian countries have all the expertise and experience in cell manufacturing, with China leading in LFP. So I'm just wondering, how do North American companies and governments collaborate while also diversifying? Ali, any thoughts there?
Yeah, so in my view, IRA is a great initiative to promote North American battery supply chain. It temporarily bridges the price gap, especially between the nascent local battery industry and the Chinese companies, which creates a cushion to protect the fragile domestic supply chain from the fierce competition abroad until it upscales, lowers the cost, and becomes competitive. In terms of the geopolitical tensions, diversifying the supply chain away from China, which has a vast dominance on almost all of the parts of the supply chain, it is very crucial. So it is very essential, very fundamental for the governments and the industries to collaborate with each other in terms of legislations, incentives, and so on, to let the industry grow until it finds speed and become competitive in terms of the price and some other features with the rest of the world.
Thanks, Ali. Dan, any thoughts from you?
Yeah, look, Ali, you're absolutely right. Calibration is key. And while the IRA does help incentivize and equalize the playing field, it has the unintended consequences of tying us more deeply to China's NMC raw material supply chain. I think both, as I pointed out, and Ali also did earlier. So we can't copy China and expect to diversify and compete, but we can take a page out of their playbook, that's for sure, by learning from them and other expert nations abroad until we are self-sustaining, and in fact, restricting and clawing back ownership from China as we progress and learn, so that we end up with our own independent know-how and supply chains. Governments have to create economic conditions and environmental incentives that nurture companies while they grow in volume to compete with China. Um, Governments must incentivize and leverage domestic refining capacity by putting all the cathode ingredients on the critical minerals list, not just the typical sort of nickel and cobalt ones, but everything that fundamentally goes into a battery. This and the cathode. This must be done without, or actually must be done while purposefully learning from and ramping down reliance on China, rather than just kind of cutting it off directly. And we must do it while leapfrogging their entrenched and environmentally impaired supply chains. And by eliminating waste, we can then begin modularizing cathode plants, for instance, for easier permitting, faster deployment, and siting on a much wider range of industrial lands. This is at the core of NanoOne's recently formed partnership with Worley, a very large Australian engineering company. We will design, market, license cathode plants together, starting with LFP, to accelerate the large-scale adoption and formation of secure and cost-competitive supply chains in the battery market. So LFP is coming to the rest of the world in a big way. It's not really a matter of if, but how, who, when, and where. And it's up to us to figure that out as we push into it.
Some big questions there. Thanks very much, Don. Just before we wrap up today's episode, I wonder if I could ask you for your thoughts on what electric vehicle driving ranges could potentially look like by the end of this decade.
Yeah, I would say if you asked this question 10 years ago, I would have answered a different answer. So probably now with more spread of the EVs, I've seen my friends and family having an EV without particular problems. So that range anxiety, which was more like a sentimental factor, has been alleviated to a large degree. So I would say I would require something like 500, 600 kilometer range, which is already in production, is already available in the market. Types of customers, of course, depending on their lifestyle.
Yeah. Dan, what do you reckon?
Well, look, long range is nice to have, especially for the occasional road trip. Just like it's nice to have 4-wheel drive for the occasional snowstorm.
Sure.
It's important. But the large battery that you put in the car for that adds cost, and most days it just sits parked, and that requires even more mining, processing of critical minerals. So there's a big sort of environmental and sustainability impact for having long range electric vehicle batteries. In fact, you could spread those batteries out between more cars. You can actually electrify a larger part of the fleet, and I think that's kind of another way to look at it. So look, I believe we have to make batteries smaller and more affordable to serve the average rather than the peak needs. Or we need to put those larger batteries to work in robotaxis or in supporting the grid. And that way the utility of the battery goes up and the sustainability of the raw materials that is in them goes up as well. So look, and I'll leave listeners with one further thought. I've been driving an electric vehicle for 7 years, and when charging my EV on road trips, you know what? I get a coffee, I go for a walk, I do email, I have an app. All of these things I would have done at my destination anyways. So there's no wasted time at the end of the day. And you know what? I arrived more relaxed because I wasn't trying to beat my last record to the mountains. So look, changing our habits is all part of the net zero transition. And I state that this year just as an example.
I like those ideas. Thanks very much. Unfortunately, that's all we have time for today. A big thank you to Ali and Dan for taking the time from their busy schedules to join Autology. And thank you to all you listeners for tuning in as well. We would love to hear your thoughts on today's episode at our autology@svglobal.com email, and you can find out much more at autotechinsight.ihsmarket.com. Don't forget to hit the subscribe, follow, and like buttons to stay on track with the latest Autology podcasts. And we look forward to you joining us again in the next episode. Bye for now.
Thank you.